Now coming to the what you can say, not applications, we'll come to the explanation of Boyle's law according to the kinetic molecular theory of gases. According to, see, now we have taken a cylinder here and we have taken some gas here. Alright, we have applied some pressure here. We have applied some pressure, that is P1, and the gas which is present is V1. Now when you are increasing the pressure, what happens is that the space which is available to the gas molecules is becoming less and less. Is that right? When you are increasing the pressure further, so the volume will become less and less, due to which those molecules will go and strike the walls of the container. Those molecules will move more vigorously because the space is decreased, and these molecules will go and strike the walls of the container. When it will strike the walls of the container, so the pressure applied on the walls of the container is the pressure of the gas present inside the container. We have studied already in kinetic molecular theory of gases, I have said it. Alright, the pressure of the gas inside the container, how do we measure? The pressure of the gas inside the container is nothing but the pressure applied by the gas molecules on the walls of the container. So hence, when I am increasing the pressure externally, then how the pressure of the gas increases, that is what I am explaining you. Because when I am increasing the pressure externally, the volume is decreasing. So whatever the space available for the gas molecules, number of molecules is not decreasing, number of molecules remain the same, but the space which is remaining for the gas molecule, that it decreases. And in that space only, the molecules will strike more vigorously, more faster, and it will strike the walls of the container. So previously, what was the force which was striking the walls of the container? Now the force will be much more vigorous, it will much more be faster. Alright, so hence, as the force which is striking the walls of the container is increasing, that is force per unit area increases. So hence, what is that force per unit area is known as pressure. So pressure increases. So hence, for that particular reason, when you increase the pressure externally, alright, the pressure applied by the gas molecules also increases. This is being explained by the kinetic molecular theory of gases. And as a result, you can see that on increasing the pressure, the volume also decreases. Fine. Now what is the applications or the significance of Boyle's law in your day-to-day life? See, when you go higher and higher, when you climb to a mountain, you take an oxygen cylinder or you feel some breathlessness. Why? Because in the what you can say lower region, the air is more dense, but as you go higher and higher, the air becomes lighter and lighter, it becomes less dense. That means the number of oxygen molecules decreases, and hence it becomes difficult for you to breathe. Due to this reason, you carry oxygen cylinder. So what I said, that is pressure increases, volume decreases, because as you go higher and higher, the pressure is increasing. Alright, clear? But the volume is decreasing. For that particular reason, the air becomes thinner and thinner, and as the air becomes thinner and thinner, means it contains less number of molecules of oxygen gases, and due to this reason, it becomes difficult for you to breathe, and hence you carry oxygen cylinder. For that reason, the mountaineers or the people, those who are climbing the mountains, we can say that, like our army jawans and all those things. Alright, they carry oxygen cylinder with them. Alright, whenever they feel breathlessness, of course they are given special training for that, but whenever they feel breathlessness, they carry the oxygen cylinder and they breathe that particular air. Alright, fine. Now next is that, what you find is that when you are filling some air inside a balloon, what happens? Not only the volume is increasing, but also the pressure is also increasing. Alright, clear? So in this way, when the balloon is inflated, the volume as well as pressure increases. Alright, what you find is that at constant temperature, it seems that the Boyle's law, it seems to violate, but actually the Boyle's law is not violated, because as we are inflating, as we are, that is blowing air to it, the mass of the air getting enclosed, alright, inside the balloon also increases. Alright, because as you are blowing more air to it, the mass of the air also increases. But what I said, for a given mass of a dry gas, your mass does not remain constant, the mass is increasing, isn't it? Initially it seems that as I am blowing air to it, the balloon grows in size, means the volume increases, pressure also increases. So how the Boyle's law is obeyed? Of course it is not obeyed initially. But if you look at what is happening as you blow air to it, the mass of the air, the mass of the gas inside the balloon, that also is increasing now. Does the mass remains constant? No. The mass also increases. Then how you can apply the, what you can say the Boyle's law is not obeyed? Of course the Boyle's law is obeyed here. because here the mass is increasing, so the volume is increasing as well as the pressure is increasing. Got it? Clear? So thus increase in the number of molecules, this into number of molecules, hence Boyle's law is valid only for a definite mass of gas. For that reason I want to say about it. Alright, so these are the applications of the Boyle's law, we can say that. Clear? So we have some more numericals upon it, but that's a main basic of this particular chapter that we'll do it later. Okay?